Hello, everybody. We are looking at the valid parenthesis problem on LeetCode, a very famous problem indeed, and an easy problem. Let's take a look how it's done. So, what the problem statement is, we are given a string S. Okay, it's made up of these characters. These are opening parenthesis, opening braces, and opening square brackets. We need to determine if the input string is valid. And what is a valid parenthesis? You may already know it, but here it is defined. So if an open bracket must be closed by the bracket of the same type. So parenthesis closed by a parenthesis, square bracket by a square bracket, and a braces, curly braces by a curly braces. Open brackets must be closed in the correct order. If I'm opening it, it should be closed first. So I cannot have it's opening, it's opening, and then closing like this. As you can see, if I am opening it later, it should be closed first. This is an invalid case. Every close bracket has a corresponding bracket of the same type. So any close bracket, something like this, should have an opening bracket corresponding to it. So the bracket should be over here, not over here. It should not be something like this. You need to open first and then close. I think this is the basic parenthesis concept. I think we have studied this in school in a math class. So we know how parentheses are opened and closed, right? This would be a valid. This would be a valid. This would be an invalid. Okay. Parenthesis should be closed by a parenthesis, not a square bracket. Over here, this is valid. Right? Now let's take a look. How do we solve this problem? So over here, there is a data structure we can use, and maybe you have guessed it already. That is stack. So how do we solve this problem using stack? You take a stack over here. You have a string. Let's take an example. I have something like this, this, and this. Now we know this is valid, right? Now let's keep a pointer at the first index. And every time we have an opening bracket, we push it in the stack. Every time we have a closing bracket, we check if it is matching with the top element. Check with the top element. If it matches with the top element, okay, if it matches, you pop. We basically say, okay, this part of the problem is looking good. If it does not match, then that is a problem. If you have something like this, you have an opening and you have a closing of square bracket, it does not match. In this case, it would not match. You have a parenthesis over here, the square bracket is coming over here, they do not match. So you can say, okay, this is invalid. Basically, it's not an answer, it's not valid. That's pretty much the algorithm. Let's try to run it over here. We have an opening bracket, push it over here. The next is a closing. It's a parenthesis, it's closing, it's corresponding to they are both the same type. So in this case, opening, you push it. Closing, check with the top. Is it matching with the top? Yes, it's matching with the top. So pop this element out. Now let's go to this element, opening square bracket. The next element after that is opening braces. The next element after that is closing braces. We have a closing. Check with the top. Checking with the top. Does it match? It matches. So remove this element from the top of the stack. Let's remove it. We are done with this. Let's look at the square bracket which is closing. This is a closing square bracket. So we are not going to pop it. We are not going to push it. We are actually going to pop it because they match. So we pop this element out of the stack. So now the stack is empty. Now the next condition over here would be, how do we know, how do we know if once we are done with the stack, but once we are done with traversing through the string, how do we know we have a solution? Over here, we can say if stack is empty, which means we found everything, right? We found all the openings and all the closings. The stack is empty. It's a valid case. If it is not empty, it's an invalid case. That's how the algorithm goes. Now let's take a look at the code. I need a stack. I'm going to need a map which maps brackets. I need a map of brackets. I should correct the spelling, brackets. Over here, I want to map the closing bracket with the opening bracket, and I want to do it because uh, when I encounter a closing bracket, I want to see if the top element of the stack is an opening bracket. You would understand it better later in the code. This is a opening bracket. Opening, sorry, the closing and the opening, and I would start with a closing and an opening. Now let's traverse through the string that is given to us, which is S. For character in string, first of all, I want to check if the character is in the opening uh, class, like is it opening or closing? If it is an opening, I want to append it in the stack. Otherwise, I want to check if what is the other possibility. If it is not an opening, it's a closing. Now there are two possibilities in a closing. Either it matches with something on top of the stack, the element on top of the stack. Either it matches with its corresponding bracket, or it does not match. If it matches, you pop that element out of the stack. If it doesn't match, then you have a problem and then you return false. You say, okay, it's not a valid uh, string. So if stack, the top element of the stack, if it is not equals to the brackets corresponding to C, so we have a closing bracket which corresponds to an opening. We can see if the element on top of the stack corresponds to the bracket we are on right now. If this is the case, if it is not matching, you can return a false that this is not a valid string. Else if you can say that, if this is, or I should write it something like this. Let's say we have else here, and I can say if this is the case, else let's return, or not return, but if the top element matches with the current element, then I should pop. pop out of the stack. Now, there is one edge case which we are missing. What if stack is empty? These operations are only valid if the stack is empty. If the stack is, not empty. Instead of else, it should be else if. And over here, what we can say in the else condition, what if the stack is empty? If the stack is empty, it does not have anything open, but we are receiving a closing, that is a problem, right? So we would say this is a problem, return false. Now, we loop through all the elements. What if we had a string where everything was open? If everything was open, nothing was closed, none of these statements would be hit. So we would not return false from here. We need to find a way to check for that condition. So we can do that using if the length of stack is equals to 0, we can say we have a valid case. True. Okay, if the length of stack is 0, stack is empty, this is a valid string. Otherwise, return false. So that's the code. Let's try to run it. We have a syntax error. And what is that? I am not using colon over here. I should be using colon. It's a map, not a list. Okay, else if should have a condition, right? I said stack should not be empty. So how do we check that? If length of stack is greater than or equal to 0, in that case, oh sorry, greater than 0, not equal to 0. In that case, it is not empty. Let's run it again. It's passing. Let's submit that. We have a pass.